Let's talk about our lessons this week. We've got 5.06 and 5.08. 5.06 is the sigma notation. That's right, Alexis. You're here now. Hopefully, it'll work well for you. 5.06 is sigma notation lesson. So, we're going to look at that first. Then, we're going to look about graphing sequences and series in 5.08. So, this was created by a guy called Leonard Euler. Not Bueller. That's a different guy.
Bueller. Bueller.
No, this is Leonard Euler. Euler was born back in 1700s. He was born in 1707, and he contributed a lot. He was the one that figured out we can use I as an imaginary number. That was Euler. Using the symbol pi, we know what the symbol for pi looks like. That was Euler's idea. Function notation, the f of x, that was Euler's idea. And using E, that was all Euler's idea. So Euler was quite the guy. He added I and the symbol for pi and E and f of x. All of that was him. So another thing he contributed to what we're going to look at today is sigma notation. So sigma notation looks like this, and it's used for sequences. That's a sigma. That's a Greek letter called sigma. And we can write a sequence like this. Okay, that's writing it. Let me separate that there. That's writing the sequence in sigma notation. Sigma notation. Now let's talk about what that means. Looking at that, it's like, okay, that looks pretty confusing. Not something we normally see. Let me turn on the lamp here so that helps it. Focuses a little bit. All right, focus in there well. All right, so this is saying this is a sequence that uses this arithmetic value right here. And n starts at 1 and goes to the 6th term. So we can figure out what the sequence is by substituting these values. So when n equals 1, we've got -1 plus 4 times 1, which is -1 plus 4. So the first term in this sequence is 3. Because when n equals, the first term would be 3. When n equals 2, right, so now it's plus 8, it equals 7. When it equals 3, it'd be plus 12, which equals 11. So we can see this goes up by 4 each time. See, which means when we substitute 6 in there, and -1 plus 4 times 6, that's 23, because it's -1 plus 24. So this is sigma notation for this sequence right here, which is obviously an arithmetic sequence. It's just adding 4 each time. So any sequence we have, whether it's arithmetic or geometric, we can write in sigma notation. But the important thing to understand is what these numbers mean. That means it starts with the first term and ends with the 6th term, this particular sequence that we're looking at. And so generally, this sigma notation, which you'll see this sometimes, it'll have a little points like that on it too, is where we take the sum, right? So the sum, we would add all those together. 3 plus 7 is 10, 10 plus 11, 21, 36, 55, 78. So 78 is our sum of that. And we use sigma notation to do that. So you either add them all together. So the sum of the first 6 terms of -1 plus 4n equals 78. Use sigma notation to notate the sum of that. And we can do it by just adding these together like we did this. We just add all those together like this. Or you can also use the arithmetic series formula, which we had S sub 6 of 6 divided by 2 times the first term plus the sixth term. Right, so S sub 6 would equal 3 times 26, which equals 78. Yeah, we learned this way before. This is just a simpler way if we were write out all the terms. Now, if we're summing up the first 25 terms, we probably would rather go back to our formula, go back to our, let's see, that's arithmetic. I need to get the right page. We go back to our arithmetic series formula. And I'm not finding it. I got all my notes from last week here. I'm finding my geometric stuff. All right, but we'll get there. Oh, A plus N. Right. Oh, yeah. So, yeah, when we know the nth term. So that was the formula we used. N divided by 2, A1 plus AN, because we knew N was 6. We knew 3 and 23. We knew the first term and the last term. So this was our sum formulas from arithmetic sequences, series, where we know the first and the last term. We could use either one. If we didn't know the last term, we could use that. So we don't want to get rid of these. We're keeping these notes handy because they're going to tie right in with what we're doing here with sigma notation. So let's look at another example here. Let's try. Okay, given this arithmetic series sequence, 8, 3, -2, evaluate n equals 4, 7, A sub n. Okay. Now here's the thing. They didn't give us what A sub n equals. They just said whatever the sequence is, right? We need to figure out what this sequence would be, A sub n. What is the A sub n for that? For this one, A sub n, the sequence equals -1 plus 4n. That's what A sub n was. This one, they just said, whatever this sequence is, I want you to find the sum of the 4th through 7th terms. The 4th through 7th terms. Well, of course, the easy way to do this, since it's just the 4th through the 7th, we can just continue this on. So the 4th term would be, let's see what's happened, -5, -5. So -7, -12, -17, and -22. We can just add those 4 up and get an answer for that one. That's not so bad. But what do we do if it's something more difficult than that? Because this one's just those terms, 4, 5, 6, and 7. Well, let's figure this out. Somehow we've got to figure out what that sequence would be. So let's go back to our explicit formula for arithmetic sequence. All right, so we know the common difference is -5, and we know what the first term is. And let's see, so A sub 1 equals 8, because that's our first term. Our common difference equals -5. So that's all we need for this, right? So A sub n would equal A1, which is 8, plus n minus 1 times -5. This is times -5. So I need to put that in parentheses. So it looks like it was just -5. These two are multiplied together. So let's do that math. 8 N minus 1 times negative 5. That's negative 5n. Negative 1 times negative 5 is plus 5. So this simplifies a sub n, 8 plus 5, 13 minus 5n. So we're finding sigma n equals 4 to 7 of 13 minus 5n, because that's what it simplified to. That's what it simplified to. Now, again, for this, we just have 4 through 7. So now we can say 13 minus 5 times 4. Well, 13 minus 5 times 4 is 20. 13 minus 20. So that's negative 7. That's what the fourth term is. Oh, fourth term, which, again, we can easily calculate this. And so it's easy to double check our work. A sub 5 would be 13 minus 5 times 5. The 13 minus 25 is negative 12. A sub 6, 13 minus 5 times 6. 13 minus 30, negative 17. A sub 7 equals 13 minus 5 times 7, or 13 minus 35, which is negative 22. Then we just add those up. So negative 19, negative 36, negative 58. So this equals negative 58. So this is just another method of finding the sums, just like we found the sums there, but using sigma notation. Notice if we used this formula to do this, which we started with these formulas, start with this explicit formula, this would say a sub n equals 8, and then we had negative 5 times n minus 1. That's the formula we would used to use, but that would simplify like we did here when we multiply that negative 5 into the parentheses. Simplifies this. This is the exact same sequence. These are the same sequence. This is leaving it in that form like this. This one's just simply simplifying that, doing the math, getting rid of the parentheses, and simplifying it. So that's an important way to convert to sigma notation, knowing that this is going to tell you something a little bit different, but you should get the exact same answer. So let's see. With a geometric sequence, so we need to look at a geometric sequence. It works very much the same way. If I can find, oh yeah, this is a good one here. Okay, let's look at a geometric sequence. So let's say we have this sequence. 5, negative 10, 20, ... And we want to evaluate, that's a terrible sigma. We'll put the little points in there, make it look more like a sigma. N equals 1 to 8. A sub n. Okay. So again, they didn't give us any type of equation. They just gave us whatever that sequence is. Sum up from 1 to 8, the first 8 terms. So A1, the first term is 5. You see that right there? This is not arithmetic because it subtracts 15 and then it adds 30. So obviously, we're not arithmetic. So it's got to be geometric, right? Unless it's nothing. But since we know we're trying to solve a geometric, this is a geometric sequence. If we take 5 times negative 2, 5 times negative 2 is negative 10. Negative 10 times negative 2 is positive 20, and so on and so forth. Negative 40 would be our fourth term. So our common ratio is negative 2. All right, so let's see. All right, so if we go right here, we've got the explicit formula for a geometric sequence. A sub n equals the first term times r to the power of n minus 1. All right, so let's substitute what we know in here to find out what the eighth term is this. So we need, because we're going from the first term to the eighth term. So a sub 8 equals a sub 1. Let's pull this back to just to refresh our memory here. A sub 1. So a sub 1 is 5 times r negative 2 raised to the power of n minus 1, raised to the power of 7. I can put it inside or outside the parentheses, because either way, I'm just taking negative 2 to the 7th power. All right, so negative 2 to the 7th power. Let's go ahead and pull up our calculator so we don't make a mistake on that. Okay, so 2 negative raised to the power of 7 is negative 128. 5 times negative 128. So that equals negative 640. We can check that just by times 5. Negative 640. That's what goes right there. So now we have our eighth term. So we have our choice on using the formulas we already knew. We can either use the recursive because we know the eighth term, or we can just use the explicit where you only need to know the first term and that. Well, since we've calculated, let's go ahead and use the recursive formula. So the sum of the first 8 terms, since we're starting with 1 and going to 8, this is the first 8 terms, that works nicely, is the first term, which is 5, minus, and this uses the 8th term, which is negative 640, times negative 2. Negative 640 times negative 2. And all of that is over 1 minus negative 2. Okay. So let's simplify what we can. So this is 5 minus, and these two are negatives being multiplied each other. So let's pull up our calculator. Clear that out. We're doing negative 640 times negative 2. 640 negative times 2 negative. 1280. So now this is simplified to 5 minus 1280. 1 minus negative 2 is a positive 3. And we subtract the negative. See if we go 1 minus negative 2, it's a positive 3. 1 minus negative 2. So let's see. So 8th term again, the sum of the first 8 terms. 5 minus 1280 is minus 1275 because it's a positive 5 and a negative 1280 over 3, which that's negative 425. So that's what the first 8 terms add up to be, negative 425. So what if we did the other way where we check them all? Well, we would have to find a sub 1, a sub 2, a sub 3. So it'd be 5, negative 10, 20. The fourth term would be, again, taking that times negative 2, right? So there'd be negative 40. Take it times negative 2 to find the fifth term would be a positive 80 times negative term, negative 2 times negative 2, and then take that times negative 2. So that is 1, 2, 3, 4, 5, 6, 7, 8. There's the first 8 terms. So if we add all those together, do 5 plus negative 10 plus 20 plus negative 40 plus 80 plus negative 160 plus 320 plus negative 640. Hey, look at there. Negative 425. So you can do this way if you like, but having this formulas that we had, we can jump straight to the negative 425 with them. So I guess the other question we have in here, though, is can we simplify and find what a sub n is using either of these formulas? We understand the sums. So basically, you're looking for sigma notation. Is looking for the first term to the eighth term. Understanding sigma notation for whatever the sequence is. Okay, whatever the sequence is, whether it's geometric, whether it's arithmetic, whatever the sequence is. This is just saying sum up the first to the eighth terms, which we did right here with a negative 425. All right, and then we did it over here on arithmetic sequence. Sum up the first six terms. There is an equation we were able to simplify for that, but basically we just took these first six terms, add them up, and it equaled 78. 78, when we add all of those up. So just understand sigma notation. That's taking the fourth through the seventh term. The fourth through the seventh term. So we didn't care about the first three terms. Those were not part of our calculation because this said start at the fourth, which is right there. And when we added all those up, we got negative 58. So if you want to try one of these other methods where we're using the formula, you can always double check yourself by just simply adding, finding each term and adding those together. All right, let's talk about lesson 5.08. Let's kind of leave 5.06 where we got it there. It's just sigma notation of doing the same thing that you learned last time, taking the sum of equations. But let's talk about graphing, and I will show you here that I have put this in our Google Classroom. Let me put our Google Classroom up here. I've added a sequence plotter. Desmos does not do this well. So there's another website called GeoGebra. And when you go on this, it's got, well, that's got a formula already in there. So we can delete the formula that's in there. Delete the formula that's in there. So let me show you how to use this, because it starts out with the one they have as a sample in this program already is not real good for us. So delete that. So when you delete it, this graph will disappear. Go up here to home and click that little home button, and it'll bring it back to where the zeros in the middle of the screen. So I can put the zeros together. Now I've got a normal graph from 1 to 30 and 1 to 8. I can lower it down, depending if I need more positive or negative. But that's better. It was going a really big number on the x's here. So you can go into the settings if you like, and you can set exactly what you want to see as the lowest x, the highest x, the lowest y, the highest y. So you can, and it's a 1-to-1 ratio right now. We can lock that 1-to-1 ratio. So as I move this, it won't mess anything up. So it'll keep it at a 1-to-1 ratio now. As I zoom in or zoom out, it'll keep it at a 1-to-1 ratio. Now, again, you may have to move the 0 from the x over to be on the 0th and y if you want it that way. Unless you need to see negative x's, you can do that. But let's look at graphing a sequence. All right, so I'm going to move this for just a moment. I want to take one of these sequences that we were just playing with. Let's say we wanted to graph this arithmetic sequence. We have a formula, -1 plus 4n. We want to change that to an x, because this is, if we're going to graph it on the xy, this would be y equals -1 plus 4x. All right, so let's put our sequence plotter up there. And let's graph that. Oh, well, it's using n, so I guess we can use n. -1 minus, plus -1 plus 4n. Let's see, does that do that? When I hit enter? Yes, it does. Okay, so this is using n's. Sum of n, -1 plus 4n. And we see the first value. I'll put the zeros over to the 0. And let me change the settings too also, so where it'll show us by ones. How do I do that? Oh, x-axis. If I change the x-axis, units, oh, no. Cross 0. Oh, I want to see the grid. Show the grid. That's what I want to see. Okay, now we can see the grid. And major grid lines. I can change those to ones. Change these to ones. So now it shows every one. All right, just changing our settings to get what you want. So we can see when n equals 1, because this is our n's, the value is 3. If I click on that, see how it's, so when n equals 2, it equals 7, 11, 15. Let's go back and look at what we were seeing here. 3, 7, 11, 15. See, those are the first 4 terms. So if we're graphing this sequence, we can use this sequence plotter to graph that. Here, I can grab this and you can move that out of the way. Now, let me ask you, there is a problem with our graph. Can anybody tell me what that is? We haven't discussed this morning. What do you think, Marion?
Isn't it not supposed to like have a line in between the points?
Oh, I love it. Yes, this is not the graph of this sequence, because this says when n equals 1.5, that the sequence equals 5. We don't have term number 1.5. We only have the first term, the second term, the third term. So we should take off these lines. That's the actual graph of the sequence. It exists at 1. It doesn't exist anywhere between 1 and 2. We don't have a 1.6th term, a 1.8th term. We only have a first term, a second term, a third term, and a fourth term. So we should not connect those. You know, we zoom out, it'll do terms forever. But notice, we don't have a 0 term. We don't have a negative first term. We don't have a negative second term. We only can have integers, no values in between the integers. 1. First one's 3. The second term is 7. Third term is 10. So when you graph a sequence, you do not connect the lines. Because anytime you connect it, you're saying that there's a value that this equals. Where that line, anywhere that line is, there's a value. That is not true with a sequence. Remember, with our sequence, when we talk about a sequence, we are limited. The domain has to be n is greater than or equal to 1 and integers only. So there is no value of 1.1. There is no value of 0.5. The domain. Now the range is unlimited. Range can be anything. Negative infinity to infinity. Right? Negative infinity. Oops, not negative 8. My infinity fell over. Negative infinity to infinity. But our domain is the number of terms, starting with the first term on Only that. So that is the big part of graphing a sequence, is that you can only have integer numbers. So let's look at another sequence here. Let me see if I can pull up another example here. So to graph a geometric series, let me see this last geometric series we were playing with. So let's see if we can do this right. Delete that. You can hit this little keyboard here and it'll pull up some other options for you. Not a whole lot of options there. F of X. It does have a few things. Okay. Our summary of that tells us, this is from lesson 5.08. Remember, our domain is restricted to all integers, greater than or equal to 1. The range has no restriction. Discrete graphs. Let's talk about that terminology. The graphs we're making are discrete, which means they're not continuous. Not continuous. Continuous, it has the lines. There's two types of graphs, continuous and discrete. Discrete is just the actual values without anything in between there. No curves, no lines. So we're making discrete graphs. Discrete graphs. So that's important to know. Here's the graphing sequences, which we did some of that for arithmetic. Oh, and this is to graph geometric sequences. Okay, this is what I need to use. A sub 1 times R times n minus 1. So let's change that. A sub 1 was 5. And it's negative 2 to the n. Let's graph that. N minus 1. There it is. That fixed our graph. That's what we needed to use, is let me make that bigger. If we want to graph an arithmetic sequence, we know how to do that one. That's using the formula. For a geometric, we use a sub n equals the first term times the common ratio raised to the power of n minus 1. That was to graph a geometric sequence. So when I did that, 5, negative 2 is our common ratio raised to the power. And I got to put n minus 1 in parentheses because I'm raising negative 2 to n minus 1 as the power, not just n. If I don't put the parentheses, it'll think minus 1 is just something happening at the end, and it'll graph everything off 1. So when it's 1, it's equal to 5. When it's 2, it's negative 10. When it's 3, it's 20. When it's 4, it's negative 40. When it's 5, it's going to be way up at 80. So this is the sequence that we had, the geometric sequence that we were using there. So negative 5, 10, 20, negative 40, negative 5, negative 10, 20, negative 40, 80. That was that. We had to use the correct formula on that. So yeah, this is good to put in your notes. This is in the end of the lesson. Well, I wouldn't say the end of the lesson. Let me show you where it's at in the lesson. If you want to find these summaries are always great to have. There it is. The lesson summary is actually on page 2 of 5.06. You click the lesson summary, it opens up that window, which shows you, well, there's sigma notation. The lower limit is the first term, the higher limit is 7, and that's the expression that's being used. So for this arithmetic sequence, 832, so this is from the 5.06 lesson, 2 times 2 to n minus 1. Then if we go to the graphing lesson that we just look at, again, this is a great place to take notes, is from the lesson summaries that are in each one. So usually they're about somewhere in the middle because they'll have a couple of pages of practice problems afterwards. Oh, it wasn't there. Here's a nice video on graphing an arithmetic sequence. So be sure and watch these videos. So let's look at page 4. Oh, there it is. Lesson summary on page 4. So you can go there and it gives you what we were just looking at. There's how you graph at a geometric sequence. There's how you graph an arithmetic sequence. And then the graph of series is different. And we can still find the slope or the average rate of change between 2 points using our slope formula. So it has the slope formula there in case you've forgotten the slope formula. If we need to know the slope between 2 points, if we need to know the slope between 1 and n equals 1, n equals 2, we can do that using the slope formula. This goes from 5 to negative 10. So we can do negative 10 minus 5, 2 minus 1. So that's the slope of negative 15. But these lesson summaries are a great place to get your notes. And then after the lesson summary, there's still a page or 2 left. So that's what gives you practice problems. Check your result. Graph this sequence or series on your own. So all they tell you here is the first 6 terms where A1 is negative 3 and the common difference is 4. So to check your work, you should have the points 1, negative 3, 2, 1, 3, 5, 4, 9, 5, 13, 6, 17 graph. That would be the graph of the first 6 terms of this sequence. So remember, it's got check your work. It's got practice problems. It's got 6 practice problems for you here. That's where you need to go and see, do I understand what I'm doing? So if you want to know if you understand what you're doing, go to the lesson, find the practice pages, and see if you get the same answer that because they give you all the answers on these practice problems. So you need to work the problem. This is graph this sequence or series, and then check your result. They want you to graph the first 6 terms of this sequence. There's 3 of them. What's the next 3? Graph them. And again, it gets where you can check to see, is this the points that you graphed? Next problem. Graph the first 6 terms of this sequence. Check your work. So they give you 6 problems to try on that. All right. A lot of crazy stuff thrown at you. I do want you to have that sequences graph plotter. So that is in Google Classroom, where you can go to GeoGebra and use that, because Desmos will always connect the lines. You cannot graph those unless you type in the individual points in Desmos. You have to say graph the point 3, 1, graph the point 4 is 5, graph the point 5, 7, or you'd have to do that point by point in Desmos, which you can do if you want to put all the points individually. But if you're going to graph the sequence, you can do that in this GeoGebra graph program that I put a link to in Google Classroom. So, all right. Questions? Or you probably need to dig into it a little bit to understand what to ask questions about. So if you have questions, I'll be happy to do what I can. Otherwise, get in there and try this. Try those practice problems and then figure out if you're having questions. I will get the grades in today at some point. I'm working on that. So you'll have those tomorrow for your grade checks. This is our regular attendance from this point on. So that means we have meets today and tomorrow for all your classes. Wednesday through Friday is only if you have less than 70%. At that point, you're required to be here. But remember, it's always an option to come to class. Oh, this is an A day. I need to change my sign up there. So we will have 3 classes this week. You can come Wednesday and Friday if you've got questions or want help with something. Doesn't matter what your grade is. So come to class and ask questions. And you don't have to stay for the whole class. I just come into class and see if anyone, first of all, attends because they have less than 70. So I see what they need to do. And then if anyone has questions, so I come to class. I don't stay an hour and a half if nobody's here. I'll stay for a while. If nobody shows up, then I'll leave class. But anyway, I will let you guys go. I'll see you Wednesday if you got questions or if your grade indicates you need to be here. But you should know what your grade is already by going to Buzz. Buzz will tell you your grade because that's the grade I need to transfer into the Home Access Center. So, all right. We will see you guys either Wednesday, Friday, or next Monday for sure because that's mandatory.